Welcome to Math 119, where we are just going to be taking a look at your inverse trig function. So first, let's start with sine. So taking a look, this is just a regular sine function. So keep in mind this graph in green is continuous. It's going to go off the page. Now, when we talk about inverses, we said, hey, what was the inverse test? Well, we said, well, for functions, at the very least, we use your vertical line test, where we said, okay, well, we can draw a vertical line, and as long as it touches once, that's great. For your inverse, to test if it does have an inverse, we have to draw a horizontal line. And if it touches more than once, which ours is going to reoccurringly touch your horizontal line, we now know that there's no natural inverse. But then how on earth do we have a unit about inverse trig if there's no natural inverse? That is because we now have to restrict your sine graph. So in order to restrict your sine graph, before that repeat starts to happen, we'll take this sliver of your sine graph and restrict its x and y values. So you'll restrict your x values at from negative pi over 2 to pi over 2. And then from -1 to +1. And so that's what you have here down below. So this is your sine graph that has been restricted. It now starts and stops at these values. We are going to include, and you'll notice that there is a nice solid dot here, so it suggests that we will have to include this value. So when it comes to your inverse functions, for your domain here of sine, well, domain for sine originally was all real numbers, and your range was between -1 and 1. And if we do the same here for your domain of your restricted, well, where are your x values now hovering? We said that they're hovering between negative pi over 2 and pi over 2. And then your range here is still going from -1 to 1. Now, once we have reestablished that now, no matter where you draw your horizontal line, it will only touch once. Therefore, we can create an inverse. Now, how does that inverse get created? Well, keep in mind what we said when we go to create the inverse graph, we end up reflecting over the x, y, or y equals x equation, meaning that all of your x and y values flip. Your domain and your range flip. So this now becomes your range, and this now becomes your domain. So your range here is going to go from negative pi over 2 to pi over 2. And your domain here will now go from -1 to 1. And we should accurately see that in the inverse. So that means all of your x and y values will go ahead and switch. And that switch happens here. So notice that we were at pi over 2 and 1, and now we have reversed those values again right here. So now if we talk about your domain and range, right, don't just take it for me to say, right, that this is now your inverse, right? Let's go ahead and actually look again at the domain and range of your inverse. Well, your domain, your x values are going to go from -1 all the way up, all the way to +1. You'll notice that we still have nice solid dots here. So your domain is going to go from -1 to +1. And your range here is going to go from negative pi over 2 to pi over 2. And again, nice solid dots. So this is now your inverse sine. So when we talk about finding your values of your angles, they should be between your domain and your range values. Now let's take a look at your cosine. So one more time, we have your cosine values, your cosine graph. Again, this is a continuous graph. It goes off the page. It's continuous. We said, okay, well, let's do your horizontal line test, and it clearly fails. That is because your domain here is all reals, and your range is from -1 to +1. So we know that it does not have a natural inverse, so we're going to restrict it. Now we're going to restrict it along this area. The reason why we take this area is that we are looking at that before any sort of repeats. If we were to restrict it as we did with sine, that notice that with cosine, because the graph shape is different, that we are going to start to get those repeats. So we have to restrict it in a different way from sine because its cosine graph looks different. So when we restrict it, we're going to go from 0 all the way to pi. And again, from -1 to 1. And we can see that right here at your orange and your green dot right here. So can you come up with your new domain and range for your inverse? Or sorry, for your cosine restriction? Well, your domain, we're going to go from 0 to pi. In your range, we're going to go from -1 to 1. So now that any point on your graph, you can draw that horizontal and we're not going to fail. We are going to pass your horizontal line test so we can have an inverse. Now, can you come up with the idea of what this inverse would not only look like, but could you come up with what its domain and range will be? Well, your inverse, right, your domain and your range now have, oh, I keep doing that. Your range and your domain switch. So your domain should go from -1 to 1, and your range should go from 0 to pi. Your x values and your y values will flip. So this should now be at the coordinate 1, 0, and this one at -1 pi, which again goes in line with, okay, my x value is 1 and -1, and my y value is from 0 to pi. So when we when we switch those, you can see it right here. Those values have now reversed. Again, that is just taking this sliver here, and then this 1, 0 is all the way up, all the way over here, 1, 0. Well, we actually can't do that here because these values are different. But notice that on your axis here, even your axis values will change. So your inverse, domain, and range go from -1 to 1 and 0 to pi. Now let's do it once more with your tangent. So your tangent graph here, right? This is your normal standard tangent graph, which you can clearly see the horizontal line test is going to cancel out. It won't pass. Therefore, if we get rid of all of the extra graph, and then instead, if we just restrict your graph to this portion, right, then we can go ahead and determine your domain and range. Sorry, your inverse. We can have an inverse, not a natural one, because we do have to undergo some restriction. So if your tangent is now all of a sudden to here, your restriction, can you pick apart its domain and its range? Well, its range here is all real numbers. Notice that we continue to go up and down. So you're all real numbers here. Your domain, however, is going from -pi/2 to pi/2. And notice that these are red dotted lines, which suggests that these are asymptotes, meaning that we cannot be at these asymptotes. So unlike sine, where we had a solid dot and we could include -pi/2 and pi/2, we are now not able to get and achieve this value. That is because your tangent, being y/x or sine over cosine, we are not able to have a 0 in the denominator. So these are locations of where your zeros, your asymptotes, would have been. So now that it does pass your horizontal line test, we can go ahead and now reverse your values. So your domain and your range can flip-flop. So your domain, we should be seeing now all reals. In your range, we should be seeing two asymptotes at pi over 2 and negative pi over 2, and we're trying to reach towards those. So we should see this graph kind of tilted on its side, which we have right here. So hopefully that makes sense as to your inverse trig, why your domain and your range look the way that they do, and why their graphs end up like this. Now we need to take this understanding and apply it to our chapter 7.6 unit.